Hi, Jim Shaw here from Crystal Group, and we thought we'd spend a little bit of time today with Jeff Goodson.
Hi, I'm Jeff.
Jeff is an electrical engineering forensic scientist. I made that title up. I thought it was so cool.
Thank you, Jeff.
But Jeff's job is to basically, if we find something that's going wrong with a product or in tech services or in production, then Jeff is assigned to go figure out what went wrong and why. And so Jeff, could you tell us a little bit about some of the equipment that you got and your process for digging down in and finding where the problems are and then what we do about them?
A good example is power supplies. We see a lot of power supplies that go bad. Sometimes the power supplies just get old and some of the electronic components have been hit hard, wore out. For example, here's one of the power supplies that we make right here. And the first thing I do is I check the performance. I make sure that all the ATX voltages going in and out are good. I put it on a load test. That load test is going to test it at about 85% of its maximum load. If it fails any test, I'll take it back here and I'll take it apart, and I got to start going through the power supply all the way from the voltage source going in all the way to the signals and voltages going out. Usually I can find out what is wrong with this pretty quick, and then I take that little subcomponent out and then I figure out what's going on with that subcomponent, and then I actually take the electronic component off of that subboard and figure out why that's going bad. We have something very useful here at Crystal Group. We have an X-ray machine, and you know how much I like that thing. I can take that board or that subcomponent or that component and put it on X-ray and figure out exactly what went wrong with that subcomponent or actual component itself. Now, if we have a trend where we're seeing that particular component going bad, then we reach out to the supplier and we let the supplier know that we may have a problem with that part. Or we may choose to opt to go with a different provider if there's a systemic problem with it.
Or there's feedback to the design team, correct?
Exactly.
And in this case, this is a crystal grown power supply. So if we need to build in additional protection, that's just one way that you help the design team to provide a better product as we move forward.
Yes.
Yeah. And so you've got microscopes here, you've got oscilloscopes, you've got thermal probes, you've got all kinds of test capabilities. Yeah. Tell us a little bit about it.
For visual inspection, I have a high power 54 power USB microscope right here. I have a lower power microscope right here. This works really well for taking pictures. It's just like the microscope that we have in the engineering lab, but it's a lot more convenient to use. And then going across here, I have a test bench. Right now I'm testing a particular card and I'm looking at its overall performance. I'm looking at its power consumption, and I'm looking at the power consumption drawn by each USB port. And moving over here, this is kind of my to-do work right here, kind of set off in the corner. And this is where I actively write my reports and all of my findings is right here. I also have a little bit of a station right here where I can check some timing, apply power to different modules, and look at the overall performance.
So one of the things that we asked you to do, Jeff, is do a good job of documenting what you were finding in these forensics. And so we've had you pull up just an example of that. Can you describe just a little bit about some of the things that you found in some of the analysis?
Sure. For example, with the X-ray machine that we currently have at Crystal Group, I can go through and I can look at damaged components. For example, this was a protection diode that had an overcurrent condition. When it had the overcurrent condition, it actually exploded, and it caused a sidewall damage to an electrolytic capacitor that it was adjacent to. This also shows me, without even taking a measurement, that my online fuse protection is good. Oppositely, it shows me when I have an open fuse. It shows me when I have damaged traces. or even a damaged component. When you have a damaged component, you're going to have the internals within the component, whether it be ceramic or carbon, actually disintegrate, and you'll see these black little speckles on them.
So that's all good information, and we write that all down in a very detailed report, and frequently we can provide that information to the customer.
Correct.
And we also log that information as kind of lessons learned or things to look out for, conditions to watch for or monitor as the product leaves the factory.
Correct. It's all documented. It's all documented within our own IRMA tracking. It's also documented in some internal databases that I've created.
Okay, excellent. Well, thank you for your work, Jeff. Certainly appreciate having you here and your expertise and trying to figure out what's going on with any kinds of these failures. They don't happen often, but when they do, we've got you here to help us figure out why.
Great. I got one more thing.
Sure.
I don't want to do that for
Thanks.
so long.